Hi everyone, welcome back to chemistry. So I'm not sure if you were able to look at the lab handout for this week yet, but this week we're actually going to do a lab about precipitation reactions, which are actually types of double displacement reactions. But in order to understand what a precipitation reaction is and how it works, we first have to talk about solubility. So that's what this video is going to be about. So solubility, what is it? So in solubility, we always have in a solution, we always have a solute and a solvent. So a solute is the minority component of a solution. Or the way I like to think of it is it's the thing that we are dissolving. Okay, so a solute is the thing that we're dissolving. A solvent is the majority component of a solution, typically water, but it could be other things. And a solvent, the way I like to think of that is the thing that we are dissolving, dissolving something into. So solvent, the thing that we're dissolving something into. So let's take a look at an example because this can be kind of hard to wrap our heads around. So for salt water, salt, NaCl, is being dissolved into water, right? So what would salt be? Would it be the solute or the solvent? Yeah, salt is the thing that we're dissolving. So salt would be the solute. Okay? And then water is the thing that we're dissolving something into. So that would be the solvent. So just some vocabulary that you kind of need to memorize here. And I don't know why I have this so far. Let me move this over. Okay, so solute versus solvent. And then we can measure the solubility. And solubility is the maximum amount of solute that dissolves in a specific amount of solvent. So how much solute can dissolve in your solvent? So solubility is temperature sensitive for solutes. So that just means that the temperature of your solution determines how much of your solute actually dissolves, how much of your thing that we're dissolving will actually dissolve. And its solubility is also expressed as grams of your solute, the thing we're dissolving, in 100 grams of your solvent. Your solvent's usually water, so in this case we represent it just as grams of solute over 100 grams of water. Okay? And that's just the convention, that's just how it's represented. So when we talk about solutions and solubility, we talk about something called an unsaturated solution versus a saturated solution. So an unsaturated solution is a solution that contains less than the maximum amount of solute. And it can dissolve more solute. So what does that mean? So for an unsaturated solution, I've added some salt as an example, right? I've added some salt, but I haven't added enough where the solution is saturated, where it can't dissolve any more of the solute. So in an unsaturated solution, we can still add more of our solute and it will still dissolve. Whereas in a saturated solution, we've added so much of our solute that we've added the maximum amount that can actually dissolve. Okay, so saturated solutions contain the maximum amount of solute that can dissolve. They usually also have undissolved solute at the bottom of the container. So we're adding our solute, adding our solute, adding our solute, reaching that saturation point, and then we're seeing that undissolved solute at the bottom of the container. Okay, and saturated solutions contain solute that dissolves as well as solute that recrystallizes in something called an equilibrium process. We haven't learned about equilibrium yet. We will in the future. For now, you can just think of it like we have in the beginning our solute and our solvent, right? And some of that solute is going to dissolve, but it's a saturated solution. So we're going to reach saturation, and then some of that solute is going to recrystallize because it's already reached that saturation point. It cannot dissolve any more of our solute. So again, you don't need to know too much about this, but it's just something that is a characteristic of saturated solution. Okay, so here's a picture of that. So here's our unsaturated solution where all of our solute is dissolving in that water, right? And here is our saturated solution. So you'll notice, yeah, we've got some of our solution, our solute is dissolved, but we've also got some of it recrystallizing to form that solid at the bottom there. Okay, so more solute can dissolve in the unsaturated solution. We could keep adding more of our solute in there, and it's going to actually dissolve. Whereas if we add more of our solute in here, it's not going to actually dissolve because it's already saturated. It can't accept anymore. It can't dissolve anymore. Okay, so we said that the temperature can actually affect whether something dissolves, or how well something dissolves, I should say. So solubility does depend on temperature. For most solids, the solubility, the amount of that solid that dissolves, actually increases as we increase the temperature. So as we raise the heat on our solution, more of that solid is going to dissolve. Whereas with gases, it's actually the opposite. As we increase the temperature of our solution, the solubility of our gas, the amount of gas that can dissolve in that solution, actually decreases. So if you look at this graph over here, this is specifically looking at water. So the solubility of different solids in water. We've got several different types of solids. So we've got NaCl, which is, our table salt. We've got glucose, which is what? Those of you who have taken biology, you might know that's a type of sugar, right? And looking at NaCl, you'll notice that it's pretty much a flat line. So NaCl doesn't really actually apply to this rule. And that's why it says most, right? There are exceptions. So NaCl is one of those exceptions, table salt. It's already pretty soluble in water, and as you increase the temperature of that water, nothing really happens. It stays the same. For glucose, looking at sugar here though, notice that there is a really steep curve here. So at 0 degrees Celsius, our glucose is not really that soluble in water. I mean, it's soluble, right? But as we go to the right on our graph here, as we raise the temperature, it gets much more soluble in water, okay? And again, you'll notice that the way that we represent our solubility is in the units of grams of solute per 100 grams of water. Okay, so we have lots of water, and we're wondering how much of our solute can dissolve in that water at different temperatures. Okay, so, but like we said, so this was for solids, right? What about for gases? So like we said, gases, actually the solubility of our gas decreases as the temperature of the solution increases. So as we raise the temperature, you'll notice that each of these has a negative slope. It's going down. The solubility is actually getting lower and lower. In my environmental science class, we talk a lot about oxygen, dissolved oxygen in water, because it's very important for aquatic life to have enough dissolved oxygen in the water to breathe and to function well. So what we've noticed with climate change and with human interaction is that the amount of dissolved oxygen in our water systems is getting lower. and that can actually really affect aquatic life, which can affect other things as well. So just kind of interesting. And the reason that that happens is because as you raise the temperature, right, with global warming, as that temperature is increasing, the amount of oxygen that can stay dissolved in the water is also decreasing. So we have less and less of that oxygen able to be dissolved in that water. Yeah. So kind of interesting. And then you'll notice it for carbon monoxide and for nitrogen as well. But it turns out that only ionic compounds that contain a soluble cation or anion are soluble in water. In an insoluble ionic compound, the ionic bonds are actually too strong for the polar water molecules to break. Remember I talked about water being a polar molecule? But that's okay because we can use solubility rules to predict whether an ionic compound could dissolve in water. And that's what's shown in this table here. These are solubility rules. And please don't memorize this table. If I ever ask you any questions about solubility, you'll have this table, okay? Any questions to determine the solubility of a substance, you'll have this table. So let's break this down a little bit. So these are what's called solubility rules for ionic compounds in water. And they say that an ionic compound is soluble, okay, it can dissolve in water if it contains one of the following. Any of these positive ions, oops, I'm trying to highlight, any of those positive ions, right, cations, these negative ions, chlorine, bromine, and iodine, except when combined with any of these cations. Okay, so what does that mean? That means if you have anything else bonded to those three anions other than these, it's soluble. The ionic compound is soluble in water. If you have those anions bonded to any of those blue cations, then it's not soluble in water anymore. Okay, and this is just something that we notice in nature. And then sulfate, bonded to anything except, whoops, these cations, okay? Again, don't memorize this table. It will be given to you if you need it. So ionic compounds that don't contain at least one of these ions are usually insoluble. So here's an example of some of these exceptions. So let me zoom out a little bit. So here we have what's a good example? This one. So look at this table over here. We've got iodine right here. So normally iodine, when it's combined with most other cations, that ionic compound is soluble in water. But when iodine is bonded to lead, it's no longer soluble in water. So here we have PbI2, lead iodide. Looks like probably lead 2 iodide. When lead 2 iodide, that's what that yellow thing is dissolved in water, it won't actually dissolve. It's insoluble. And that's how you're seeing this yellow stuff in the solid kind of form there. Okay, so I want to introduce this learning check, and then I actually want to solve it with you in the next video. But let's take a look at this sentence real quick. So we can use solubility rules to predict whether a solid, which we also call a precipitate, forms when two solutions of ionic compounds are mixed. This is what we're going to do in lab this week. We're going to look at precipitation reactions and see if a precipitate or a solid actually forms and determine what that solid might be. Okay, so try this learning check out if you would like. Otherwise, I will see you in the next video and we'll go through it together.